Good morning, good afternoon, or good evening, or whatever time that you are watching this video. It is a pleasant day for you. Our topic for today is all about the measures of central tendency, the measures of position, and measures of absolute dispersion. Without further ado, allow me to introduce myself. My name is Engineer Reiner J. Enrique, ACE, ACT. If you're ready, I'm ready, so let's get it on. Allow me to introduce the objectives first before we proceed to the discussion proper. So the first objective, we have to find the measures of central tendency, and these are the terminologies that we have to define. The first one, we have the mean, the median, then the mode. Then after defining or after finding the measures of central tendency, we're going to compute it using our Excel spreadsheets. Okay, so let's start with our first slide. This is the meaning of the measures of central tendency. It is a single value that describes the center of a distribution. So, like what was said earlier, these are the mean, the median, and the mode. When we say mean, it is also known as average or arithmetic mean. It is just like obtaining the average. Like, we're going to find first the summation of our data, and then we're going to divide it by the total number of observations. Okay, the next one, we have the median or the middlemost score. But before we proceed to the determination of the median, we have to arrange first the data in ascending order. Okay, and lastly, we have the mode or the most frequent score in our distribution. Okay, we can have a multiple number of modes provided that they have the same number of frequency of occurrence. So if they don't have the same number of frequency of occurrence, syempre ang kukuhanin natin yung most frequent o yung pinaka madami. Now, next, let's proceed to the example. The sum of the values in the dataset divided by the total number of observations. This will be our definitions of the mean, and this is how we get the mean of a particular dataset. So example, consider the following: 16, 20, 2, 35, 18, 22, and 17. So like what was said in our description, we just have to find the summation of all the values and then divide it with the total number of observation. As you can see here, we have 7 number of observations. Ito yung n natin, no? So ano nga ba yung magiging formula natin dito? We have summation of x. These are the values, and then divide it with the total number of observation n. So we will obtain this value as we add them all together and then divide it with the total number of observations. Okay, for example number 1, find the mean of the following set of scores. We have there 2.5, 3.4, 4.2, 5.1, and 4.8. So, just like what we have done earlier, we are going to find the summation of the values of x and then divide it with the total number of observation. So if we're going to add them all together, so the summation of our x will be equal to 20, and then the number of observations are equal to 1, 2, 3, 4, and 5. So that is 20 divided by 5, it will give us 4. So 4 will be our mean for this example number 1. This will be the formula. And again, if we're going to add them all together and divide it with the total number of observation, we will obtain a mean which is equivalent to 4. Okay, for example number 2, the following frequency distribution lists the result of 10-point quiz given by a professor in a statistics class with 42 students. Find the mean score. This example is a little bit different with the former one because here we are going to refer to a frequency distribution list. Now, let us try to look at the table. We can see there the score and the number of students. This will be our x, and this will be our frequency of occurrence. You can see there at the third column, the fx. So it means that in order for us to obtain the result for that particular score, we have to multiply the frequency of occurrence by the score. So if we're going to multiply that, we will be able to obtain these values. So 3 times 10 will give us 30. 6 times 9 will give us 54, and so on and so forth up to the last part. And then again, if we're going to find the summation of these values or of this column, we will obtain 294. Okay, our formula earlier is just the summation of x divided by the total number of observation. So the formula in our example number 2 is almost the same, because we're just going to get the summation of our fx, that is the product of our frequency of occurrence in our score, and then divide it by the total number of observation. So apparently parang wala namang nagbago, no? We just add the frequency of occurrence here, and then the total number of observation. If you're going to counter check it, the summation of our f must be equal to n. Okay, then let us try to solve this problem. We have the summation of fx, which is equal to 294 divided by 42. Okay, if we're going to divide it, you may use your calculators with you. We will obtain 7. Okay, so the mean score of this frequency distribution is equivalent to 7. Okay, this will be the formula like what I've said earlier. We're just going to divide the summation of fx to the total number of observation, which is 42, and we will obtain an average or a mean, which is equivalent to 7. Let's proceed to another example. So example number 3, determine the student's GWA given the following grades last semester. So we have 3 different courses: Math, English, and PE. They are 3, 3, and 2 units respectively. And they have this respected grade 3, 2, and 1.25. This is just like the frequency distribution that we have solved earlier. So the only difference is it is being represented using the units. Okay, but this one is just like our frequency of occurrence, and this will be our score or our x. So we're going to create another column again, and ito yung kukuhanan natin ng summation for us to be able to get the mean of this or the average of that student. So we have 3 times 3.0, it will give us 9.0. We have 3 times 2, it will give us 6.00. And lastly, we have 2 times 1.25, will give us 2.5. And if we're going to add them all together, it will give us a value which is equivalent to 17.5. Now we have the value of the summation of fx. We can now solve for the mean or the average of that student. So the average or the mean is just equal to the summation of fx divided by the total number of observation n. So here x bar or our mean is just equal to 17.5 divided by the total number of observation, which is equivalent to 8. Okay, so if we're going to use our calculator, it will give us a value which is equivalent to 2.1 17. I just forgot the values, so that is 2.1875. So this will be the answer for this problem. So the average of that student is equivalent to 2.1875 or 2.19 for that particular semester. Now let's proceed to the determination of the median. Like what we have said earlier, what we have defined the median, this is the middlemost score. Okay, and as you can see here, we have 2 examples. We have example number 1 and example number 2. But the problem is it is not yet arranged in ascending order. So the first thing that we have to do is to arrange it in ascending order, just like this. Okay, so it is now already arranged in ascending order, and let us determine the median of each number. So for number 1, we can already see the middlemost score that is equivalent to 119. So the median for the first example is 119, and then for number 2, so we can see there are 2 median, but we only need 1 median. So ang gagawin natin, we have to find the average of that median. We have 315 plus 367 divided by 2. It will give us an answer which is equivalent to 341. And that is how we solve for the median. So let us solve for the median also of this problem. So example number 1 again. We have 2, 3, 4, 5, 6. It is already arranged in ascending order. So we already know, or we can say that 4 is our median. And for example number 2, we have there 2, 3, 4, 5, 6, 7. Then the median will be 4 and 5. But again, hindi tayo pwede magkaroon ng dalawang median. That's why we have to divide it into 2. We have to add them all together and then divide it to 2 to find its average. Just like this. Okay, then the median, the new median will be equal to 4.5. That is how we solve for the median or the middlemost score. Don't forget the first rule in determination of the median, that we have to arrange first the data in ascending order before we proceed to the determination of the median. Okay, and then the next one is the mode. It is the most frequent score in our data set. So for example, consider the following. Number 1, 45, 22, 63, 78, 99, and 22. So it is very visible that the most frequent score is 22. Then followed by number 2, we have there 67, 89, 34, 90, 23, 53, 22, 34, and 53. So like what I've said in our previous discussion, that we can have a multiple number of modes, or we can have multiple modes provided that they have the same number of frequency of occurrence. So here we have 2 modes in problem number 2. So since 34 and 53 have the same number of frequency. So, and lastly, we have number 3. We have 68, 97, 61, 85, 38, 29, and 11. We can see that there are no mode. So there are times na hindi talaga tayo nagkakaroon ng mode, provided that these values or there is no value na nauulat dun sa ating distribution. Okay. We also have a relationship between the median and the mean, and that is what we call the mode using the empirical formula. Okay, let me just add it here. So we have our empirical formula in determination of the mode. So ano nga ba yung relationship ng median tsaka ng mean in the determination of the mode? So it is just a 3 median minus 2 mean. Okay, this will be the relationship between the median and the mean. So in order for us to obtain the mode, we can use the empirical formula. But this is just an approximation of the value of the mode. So if it is not being asked in the problem, we must not use the empirical formula. No, kapag sinabi lang sa problem, nagagamit tayo ng empirical formula, that's the only time that we're going to use it. But if it is not stated in the problem, do not use empirical formula. Okay, let's solve for other examples. Given the scores below, identify the mode. So for number 1, we have there 2, 3, 3, 5, and 6. So it is very visible that the most frequent score is 3. That's why 3 is our mode. And for number 2, we have 2, 3, 3, 4, 5, 6, 6, and 7. It is also visible that we have 2 modes there. They have the same number of frequency of occurrence, which is 3 and 6. Okay. These are the mean, median, and mode. Now, for application, let us try to solve this problem. Okay, scores of 14 students in statistics and probability midterm exam. We have the table there. We have to find the mean, the median, and the mode. Okay? If you want to, you may pause the video for a while and then solve for the mean, median, and the mode. So approximately, you can solve this in about 2 minutes. Okay? But for now, let us proceed to our answer. So the first thing that we have to do, in order for us to determine the median, we have to arrange it in ascending order. So, i-arrange din naman natin siya mamaya. So, from the start, let us arrange it so we may determine the mode also. Kasi mas mabilis nating ma-determine kung alin ba dito yung frequent score if the numbers or elements of the set are already arranged in ascending order, or the data is already arranged in ascending order. So for the application, let us now look for the mean, or the average. So if we're going to find the summation of these numbers, it will give us 1,133. So mean is just equal to the summation divided by the total number of observations. So we have there, mean is equivalent to 133 divided by 14. So it is also equal to 80.93. So that is our solution for the mean. Now for the mode, it is visible that the most frequent score is 80. And then for the mean, let us try to look at these values. So we have 14 observations, and then the middlemost score must be between the 7th data point and the 8th data point. Our 7th data point is equal to 80, and our 8th data point is also equal to 80. And if we're going to find the average between those two numbers, we will still obtain 80 since they are just the same number. So in summary, this will be our answer. The mean is equal to 80.93, median is 80, and the mode is 80. We can also solve for the mode using our empirical formula. Just try solving it so that we will be familiar between the relationship of the median and the mean. Okay, for the interpretations, we have here the average of 14 students who took statistics and probability midterm exam is 80.93. That is for the mean. And for the interpretation of the median, 7 out of 14 or 50% of the student has a score above 80, or out of 14, 7 out of 14 or 50% of the student has a score of below 80. We have seen that in our distribution earlier as we arranged the data in ascending order, that our median was 80. So there are 50% of the students who got 80 and below, and 50% who got 80 and above. So for the mode naman, this is the most frequent score, and we have observed that this is equal to 80. Okay, now we're going to find the median, the mean, and the mode using the Microsoft Excel. So find the mean, median, and mode of the following set of scores in Excel. We have 13, 16, 18, 21, 24, 22, 12, and 13. So you may pause the video for a while and then type these values in the Microsoft Excel. Okay, these are the values that we have seen in our problem earlier, and I have just opened my Microsoft Excel so that I can show you how it works. Now let us just try to solve it using our conventional solutions that we have tried earlier. Now for the mean, this is just the average, and if we're going to use Excel, we have to find first the sum and then divide it with the total number of observation. So that's just equal sum, and then we just have to select these values, then divide it with the total number of observation, which is equivalent to 8, and it will give us the mean for this problem. So that's very easy. But there is an even easier method than that. Now, meron pang mas madali pala doon, no? We can just type average. This is one of the functions of Excel to determine the average or the mean of the scores. And then you just highlight the cells that you want to get the average. Then close it with parentheses, and once you press enter, it will give you the same answer as what we have done in our previous example, in our previous steps. Next, for the median, Always remember that the first thing that we have to do in determination of the median is to arrange the score in ascending order. So in Microsoft Excel, that is very easy because you just have to select the cell, right click, sort it in from smallest to largest. Okay, and Tanan! Okay, it is already arranged in ascending order. And as you can see here, the middlemost score was these values. Okay, so let me just highlight it with a red color. That is 16 and 18. If we're going to get the average of 16 and 18, it will give us 17. So the median is equivalent to 17. But again, there is an easier way for us to solve that. So this is just equal to the median. So just type in median and then select the data wherein we want to find the median. And then press enter. Once you press enter, it will give us the median for that answer. Next is for the mode. For the mode, this is just the most frequent score. According to what I have said earlier, it is very easy for us to determine the mode, especially when the data are arranged in ascending order. So as you can see there, the data are already arranged, and then we have seen that 13 as the number that is being repeated the most. So the mode is equal to 13. And again, even without observation, we can still determine the mode. This will be the formula that we have to input, that is equal to mode, then multiply, and then open parentheses, and then select the cells wherein you want to get the mode. And once you press enter, it will give you the mode of that problem. Okay, again, we can have multiple values of mode provided that they have the same number of frequency of occurrence in our distribution case. Okay, and that is how we solve for the mean, median, and mode using our Microsoft Excel. Okay, now as part of your exercises, you have to do the abstraction critical thinking on page 59, numbers 1 and 2. Okay, you may also use Microsoft Excel if you want to. So put all your learnings there. That is to be submitted to me on Brightspace, and you have to submit that before the midterm examination. Okay, now let us proceed to the next lesson, which is all about the measures of position. So for the measures of position, we're going to define all different terms also, just like what we have defined in the measures of central tendency. Okay, the terms that we have to define are the terms percentiles, quartiles, and deciles. So again, let me proceed with the discussion proper. Let's discuss what percentile is all about. These are positional measures used mainly in educational and health-related fields to indicate the position of an individual in a group. Okay, this is different. Take note that this is different with percentage. This is always the misconception of the people or of my students, that when it comes to percentile, they are always referring it as the same with the percentage. But in fact, and in reality, it is not. Okay, because when we say percentile, these are just positional measures. Okay, it is denoted by P sub x, and divide a set of data into 100 equal parts. It is used as positional measures to indicate what percent of the data set have the value less than the specified value. So for us to be able to understand percentiles further, so let us have some examples, and let us differentiate percentile with percentage. So again, percentile is not the same as percentage. So here we have example: if a student gets 72 correct answers out of 100 on a test, they earn 72%. And the second example, if a score of 72 correct answers correspond to the 64th percentile, then they did better than the 64 other students in the class but still receive a score of 72%. The first example is pertaining to the percentage, wherein we just divide the score that the student obtained to the total number of score, or the total number of items, that we can get percentage there. but percentile is a little bit different. This is just positional measure. So in our example, the 72 correct answer correspond to the 64th percentile. If we divide the data set of all the students who have taken that, that student was just located at the 64th percentile. So that person did better than 64 of the other students in the class, so but still receive a grade of 72%. That's the difference between the percentile and the percentage. Again, they are not the same because percentile is a positional measure. Okay, let us have some other examples about the percentile. So Roxanne has an IQ corresponding to the percentile rank of 81 in the group of girls. If there are 25 girls in the group, how many of them have higher IQ than Roxanne Jean? Okay, first and foremost, let us try to visualize kung ano ba talaga yung nangyayari dun sa problem. Okay, this will be the percentile rank of Roxanne Jean. So this is where she was located. So let's place here the name of Roxanne Jean. So it means that there are other people who have lower IQ or even the same IQ as Roxanne. And there are also other people or other classmates of Roxanne who has a higher IQ than her, since she was just located at the 81st percentile. Like what I have said earlier, these are just positional measures. Okay, for us to be able to determine the position of Roxanne, we may use a particular formula. No, gagamit tayo ng formula para malaman natin what position yung kay Roxanne in that 25 girls. Okay. So we may use this formula, so we can have or we are solving for the number of girls who have lower IQ than Roxanne Jean. So we may just multiply 0.81 by 25 and we will obtain 20.25. Okay, it means that before Roxanne Jean, or before the IQ of Roxanne Jean, there are 20 students behind her. Now, may 20 students daw na behind sa kanya. So, it means there are 20 here. So, if there are 20 here, it means that the position of Roxanne Jean was at the 21st. Now, this will be the IQ of Roxanne Jean. Then, since they only have 25 students in the class, so we just have to subtract the position of Roxanne Jean, and then we will obtain a number 4. Okay, so there are 4 students who have higher IQ than Roxanne Jean. Okay, so or we may just subtract 25 we may just subtract 20 from 25 and then subtract Roxanne Jean, since we have to exclude her from the group, since ang hinahanap natin yung mas mataas na IQ sa kanya, and it will give us an answer which is equivalent to 4. Okay, that is how we solve problems involving percentiles. Okay, now let us define the second terminology, the quartiles. So quartiles are values that are in the quarter position of the dataset. From the word itself, quartiles. No, it came from the word quarter. So it means, unlike for the percentile that we're going to divide it into 100 equal parts, or the data set into 100 equal parts, here we are just going to divide the data set into 4 equal parts. Okay, we have the lower quartile and the upper quartile. Q1 will be our lower quartile and Q3 will be our quartile. It is also being referred to as the first quartile and third quartile, wherein the second quartile or the first quartile is just equivalent to the 25th percentile, and the third quartile is equivalent to the 75th percentile. Then let's talk about the median. These are some frequently used measures of position, the median. It is the value that is in the halfway position of the data set. It is just the same as the second quartile, and it is also the same with the 50th percentile. Okay, since second quartile and 50th percentile are just the same. Now, this will be our third terminology for this topic. We have the decile. There are values, they are values that are in position that divided the data into 10 pieces. So unlike the first two, which we have divided that into 100 equal parts and into 4 equal parts. So the deciles divide the data into 10 equal parts. That's why if we're going to compare it with percentiles, our ratio will be 1:10. So 1 decile is equivalent to 10 percentile, 2 deciles is equivalent to 20th percentile, and the 10th decile is equivalent to 100th percentile. If we're going to find the median using the decile, that is just equivalent to the 50th percentile. 50th percentile, sorry, that is for percentile. No? We're looking for the decile. So the 50th percentile is just equal to the 5th decile. Okay, that is how we convert deciles into percentiles and percentiles into deciles, or vice versa, and then the equivalence of the quartiles to percentiles. Usually, if we solve problems regarding this, we do convert deciles into percentiles to visualize this further, or that is just the same with the quartiles. No, translate muna natin siya into percentile para mas maintindihan natin and mas ma-visualize natin kung ano ba yung nangyayari. Okay, examples. Anthony is a secretary in one big company in Metro Manila. His salary is in the 7th decile. So should Anthony be glad about his salary or not? Explain your answer. So let us just visualize the 7th decile. This is equivalent to D sub 7, or the 7th decile. Okay, and this is just equivalent to the 70th percentile. Okay, and if we're going to draw a diagram, so this will be the position of Anthony, and there are 70 other people, or 70 percentile that are below or even equal to the salary of Anthony. And there are 30 more others, 30 percentile, na mas mataas naman yung salary sa kanya. So, should he be glad? So, 70% of employees receive a salary that is less than or equal to his salary. So, and the 30% of the employees receive a salary that is greater than his salary. So, our conclusion, Anthony should be pleased with his salary since mas mataas naman yung salary niya than doon sa 70 other employees. Or mas mataas or pwedeng the same lang with 70 other employees. It means that his salary is not the smallest. So, he should be pleased with his salary. Next example, Christine got the median score in the examination in the public school. If the cutoff score for passing is the upper quartile, did she pass the entrance examination? So, madali lang to, no? Just transpose the second quartile and the third quartile. Since the median score is just equivalent to the second quartile, we all know that this is just equal to the 50th percentile. Okay, and then the cutoff score will be the third quartile, that is 75th percentile. So, hindi siya umabot doon sa 75th percentile. It means, by just observing this clearly, we can say that Christine did not pass the examination. Explanation, the upper 25% is the passing score while the lower 75% is the failing score. Since Christine is included in the lower 75%, then she did not pass the entrance examination. Okay, this is how we solve problems involving percentiles, deciles, and quartiles. So let us have another example. The following measures represent the raw scores of 39 students in a 100-point examination in statistics. The raw scores were arranged from lowest to highest. So there is no need for us to arrange it in ascending order because it is already arranged in ascending order. And that is one, or that is the first thing that we have to do if we really have to get the position of the number, or we have to get the percentile tile of that problem. We have to arrange it first in ascending order. Okay, we have to find for the 25th percentile, the 40th percentile, the 65th percentile, and the 95th percentile. So first and foremost, let us know, or let me introduce another variable for us to use. So we have a variable letter k. This is pertaining to the location of the particular data point. So this will be the location of our data point. Okay, then what will be our formula for k? That will be k. It is equivalent to p sub x, or our percentile divided by 100. Then we're going to multiply it with the number of observations plus 1. Okay, this will be our formula in determination of the data point where that percentile is located. So if the given is quartile, we have to translate it first in percentile. That is just the same with decile. We have to translate it also to percentile. Okay, now let us solve for the 25th percentile and let us locate the data point, or let us determine the data point where that 25th percentile is located. Okay, now let us solve for the problem. We have here k for the 25th percentile. It is equal to p sub x, which is 25, divided by 100 multiplied by the total number of observation and plus 1. So ano nga ba yung total number of observation natin? It is given that there are 39 students. So n is equal to 39. Let me just put 39 here, then plus 1 for us to proceed with our solution. So k will now be equal to 0.25 multiplied by 40. Okay, and it will give us k is equivalent to 10. It means that this is not the answer yet. It only means that the 25th percentile is located at the 10th data point. So ano nga ba yung data point na tinatawag ni sir? This will be our first data point, second, third, fourth, fifth, sixth, 7, 8, 9, and 10. So it means that the 25th percentile is equivalent to 53 in this problem. Okay, that is just the same with the 40th percentile. Now, let us try to solve the rest of the problem. We have k is equal to 40 over 100 multiplied by 39 plus 1. So we can just shortcut the next now, yung 65 and 95. So k is just equal to 0.4 multiplied by 40. We will obtain k, which is equivalent to 16. So now, the second k, or the k for, or the position for the 40th percentile, is equal to 16. So this is 10. We have 11, 12, 13, 14, 15, 16. Okay, the 40th percentile, so p sub 40, is now equal to 60. Okay, this will be our answer for our second problem. Okay, now let us solve for the third one, which is the 65th percentile. So P65. We're looking for this. Okay, let us solve for the k first. So k of the 65th percentile will be equivalent to 0.65. So shortcut na lang natin. Multiplied by n plus 1, which is 40. Okay, if we're going to use our calculator to solve this, it will give us 26. Okay, so it is located at the 26th data point. So P sub 65 is now equal to, this is 20. We have 21, 22, 23, 24, 25. So 26 pala. So 26. So that is equal to 65. So parehas lang, no? 65th percentile is just equal to 65 also. So this will be our answer for this problem. And lastly, we have P95. So K is equal to 0.95 times 40. That is n plus 1. 39 plus 1 is 40. So K will now be equal to 38. It is located at the 38 data point. But 38 is not the answer yet because we have to find this data point. So P95 is now equal to 38 data point. Yung 38 data point natin will be equal to 78. This will be equal to 78. Okay, these are now the values that we are looking for. So, madali lang, no? We just have to apply that formula para ma-solve natin yung particular data point na yan. Okay? So, madali lang siya kapag walang decimal yung ating given. But what if may decimal yung data point natin? Okay, doon tayo magkakaroon ng problem, no? But don't worry, madali lang naman siya. I'm going to teach you the steps on how to solve that using a particular method. Okay? What if we're looking for the 33rd percentile? So, we have P33. So, we are sure that this one has a decimal since medyo hindi whole yung kanyang number. Okay. So, now let us try to look for at the location of the 33rd data point. No, or the 33rd percentile. Anong data point kaya to? So, solve na natin. No? We have 33 over 100 or just equal to 0.33. Then, multiply it with 39 plus 1. That is n plus 1. Then, k will now be equal to 0.33 multiplied by 40. Okay, then it will give us 13.2 data point. So, that 13.2 data point, we all know that this is in between the 13th and the 14th data point. It cannot go beyond the 14th data point since they are just in between. No? So, 13 and 14 lang tayo. So, ang titingnan natin, this is the 10th data point. 11, 12, 13. That 13.2 must be somewhere between here in the 13th and 14th data point. Okay, now let us try to solve this problem. Let us try to locate this. We have already located it pala. No, let us try to get the values na lang. So first and foremost, we're going to use a method called interpolation. So, interpolation, we're going to interpolate so that we can solve for the 33rd term of this 33rd percentile of this data set. So, it is now equal to, let us try to write the 13th data point first because we know that this is greater than or equal the 13th data point but can never go beyond the 14th data point. Okay, so the 13th data point is equal to 57. Then we're going to add it with the remaining 0.2 of the differences between the 14th data point, which is 58, and the 13th data point, which is 57. So if we're going to do the math, it will be equal to 57.2. That is how we solve for problems about positions or locations with decimal points or the data point with decimal. Okay. So let us try to solve another problem. What if we're looking for the 57th data point? Okay. Or the 57th percentile, sorry, not the 57th data point. We have to look for the 57th percentile. So the first things first, so kuhanin muna ulit natin yung location, that is 57 divided by 100 multiplied by n plus 1, which is 39 plus 1. Then k will now be equal to 0.57 multiplied by 40. Okay, so if we're going to solve for this, so let me just use my calculator. So I'm not so certain of these values. So we have 0.57 multiplied by 40. It will give us 22.8. So the K is located at 22.8 data point. We know that this is in between the 22 and the 23rd data point. 22nd and the 23rd data point. So let us just write 57 here. P57, it is now equal to, this is the 20th per data point. We have 21, 22, and 23. So this is where the value lies. Now between 63 and 64. Now let us try to solve for this one. That is 63 and 64. Let us write the 22nd first, then plus the remaining 0.8, then the difference between the 23rd and the 22nd data point, which is 64 minus 63. Okay, it will give us an answer which is equivalent to 63.8. Okay, this will now be our solution if we are looking for the 57th percentile. Now, let us proceed to the measures of absolute dispersion. Okay, the first thing that we have to look for is, or that we have to deal with, is the range, wherein it is just the highest score minus the lowest score. So HS is our highest score and LS will be our lowest score. In our distribution, it is very easy, especially if it is arranged in ascending order, since we can already determine the highest score and the lowest score. Okay, madali lang siya. Determine natin yung highest score and lowest score because we're just going to find the difference between the two. And that is what we call the range. The second one, we have what we call the interquartile. The interquartile or IQR, interquartile range. Sorry. Okay, we have there the third quartile minus the first quartile for our interquartile range, or it is just equivalent to the 75th percentile minus the 25th percentile. So they are just equal. And usually we do refer to this that is equal to 75th percentile minus the 25th percentile because we usually convert quartiles into percentiles for us to be able to determine what particular data point we are looking for. Okay? Now let us try to solve this problem. Find the IQR of the scores of 9 students in an examination. We have here the scores of the 9 students and we're going to look for the IQR. So sulat muna ulit natin yung formula for IQR. IQR is just equivalent to the third quartile minus the first quartile, wherein the third quartile is just equivalent to the 75th percentile and the first quartile is just equivalent to percentile. It is equivalent to the 25th percentile. Okay, let us now try to get the 75th percentile first, or the third quartile. So we have the solution. We have to look for the K first, or the position of the 75th percentile, and it's just equal to 75 over 100. Then multiply it with the total number of observation, which is 9 plus 1. Okay, K will now be equal to 0.75 multiplied by 10. So the position of our 75th percentile is just equal to 7.5 data point. Now, we can already locate our third quartile using the formula for interpolation. We have P75 is equal to the 7th data point. This will be our 7th data point and our 8th data point. Let us just write the 7th data point first, and then plus the remaining 0.5, and then the differences between, or the difference between the 8th data point and the 7th data point, which is 82 minus 75. Okay, now we have 75 plus 0.5 multiplied by 7, and this will give us 3.5. And if we're going to add this all together, we will be able to obtain 78.5. This will be our third quartile. Now, this is not the answer yet since we're looking for the first quartile pa. Okay, now let's look for the 25th percentile. So using the same formula, K is equal to 0. Direct na natin, no? That is 0.25 multiplied by n plus 1, which is 9 plus 1. So we all know that K is just located at 2.5 data point. Okay, then it is somewhere between 46 and 53. To solve for this, we may use interpolation also. That is the second data point, which is equivalent to 46, plus the remaining 0.5 of our data point, then multiply it to the difference of the third data point and the second data point, which is 53 minus 46. And now we will be able to get the answer, and it is just equivalent to 49.5. Okay, this will now be our first quartile. So since we have the value for the first quartile and the third quartile, we can now determine our interquartile range. So the IQR is just equal to the third quartile, which is 78.5, minus our first quartile, which is equal to 49.5. Okay, then the IQR will be equal to 29. Okay, this will be our answer for IQR. Now, aside from the interquartile range, we also have another method that we can use, or another thing that we have under the measures of absolute dispersion, which is what we call the outliers. And there is a need for us to determine the IQR, since that is one of the components in the determination of the outliers. So what is outlier? It is a value that lies outside, which is much smaller or larger than most of the values in our data set. It only means that the value of that data may be too much higher or too much lower than the rest of the data in our data set. No, masyado siyang mataas in comparison to the rest of the data. Parang outstanding siya. That is why it is considered as outlier. This is just like when you are applying to a job. Now, for example, you have tried applying for a job. There are times that you will not be accepted in the job, maybe because of your qualifications. Their qualifications, your credentials doesn't meet their qualifications. It means that you don't pass that lower boundary for you to make it to the job. Or in other way around, you can be more than what they are looking for. For example, you're applying for a service crew, and you have your master's degree in engineering, or you have your master's degree in the field of medicine. Then you will not be accepted in that job, since they cannot reciprocate what you have, or they cannot give you the compensation that you are looking for, since you are overqualified for the job. So that is maybe one of our examples of outliers. We can consider them as outliers since the values are extremely low and the values are extremely high than the rest of the values in the distribution list. So one way to determine if the data point is an outlier is to use the interquartile range method or the IQR method, wherein the lower boundary is equal to the first quartile minus 1.5 of our IQR, and the upper boundary is equal to the third quartile plus 1.5 of our IQR. Okay, that's why I have said earlier that the determination of the IQR is very important in the outliers. Now, let us try to solve the same problem, and let us determine if there is outliers in this set. Okay. First things first, we have to know the formula for the lower boundary and the upper boundaries. Syempre, hindi naman natin masosolve yung outliers without this. Okay, we just have to memorize this. For the lower boundary, we have the first quartile minus 1.5 of our IQR. So let me just expand the IQR. That is the third quartile minus the first quartile. Then for the upper boundary, we have the third quartile plus 1.5 of our IQR, which is equivalent to the third quartile minus the first quartile. Okay, so we have to look first for the third quartile and the first quartile before we proceed to the determination of the lower boundary and the upper boundary. Okay, in this problem, let us try to obtain the 25th percentile and the 75th percentile. Okay, for the 25th percentile, let us just write it this way. We have 25 over 100 multiplied by the number of observation, which is 39 plus 1. Okay, and we will obtain 0.25 times 40. So it is just equal to 10. So it is just located at the 10th data point. Therefore, P25 is just equivalent to 53. Okay, so meron na tayong first quartile. We just have to look for the third quartile. That is just we have to look for its position. So it is just equivalent to 0.75 multiplied by 40. Okay, shortcut na lang natin ng konti, ano? And this is just equivalent to the 30th data point. So if this is 10, this is 20, so this is 30. The 30th data point is equivalent to 70, therefore the P75 or the 75th percentile is just equal to 70. Now, we can proceed to the determination of the IQR. No, IQR is just the difference between the third quartile and the first quartile. So we have 70 minus 53. It will give us 17. Okay. Now, since we have the values of the IQR, we can now determine the lower boundary and the upper boundary. For the lower boundary, okay, we have the first quartile, which is 53, minus 1.5 of our IQR, which is 17. Okay, and if we're going to solve this all together, it will give us 53 minus 25.5, and this will give us 27.5. So this will be our lower boundary, but this is not the answer yet kasi dalawang boundary yung hinahanap natin. Now, for the upper boundary naman, we have here the third quartile, which is equivalent to 70, minus, plus 1.5 of our IQR, which is 17. Then we have here 70 plus 1.5 of our IQR. That is 70 plus 25.5. It will give us 95.5. So this will be the values of our boundaries. It must lie between 27.5 to 95.5. So the values that will go beyond this will be considered as outliers. As you can see here in our problem, we don't see values that fall behind 27.5. But we have seen a value that is greater than 95.5, and that is 100. So it means that 100 will be considered as our outlier, since it falls beyond the value of our lower boundary and the upper boundaries. And this is how we solve our outliers. So again, we have to be familiar upon the use of our lower boundary and our upper boundary, because this will be the key factor in determination of our boundaries.
Okay. Next, we will be talking about the quartile deviation. The quartile deviation can be defined mathematically as half of the difference between the upper and the lower quartile. Here, quartile deviation can be represented as QD, wherein the third quartile denotes the upper quartile and the first quartile indicates the lower quartile. So ito po yung formula natin. We have QD is equal to the third quartile minus the second quartile, and then the difference that we're going to obtain there will soon be divided into 2 for us to get the quartile deviation. Okay, kung titingnan natin mabuti, parang medyo may konting familiarity with the formula. Kasi parang yung quartile deviation ay halos kamukha ng ating isang formula, which is the interquartile range. So yung interquartile range natin, recall lang natin yung topic na na-discuss natin last time. Interquartile range was just equal to the third quartile minus the first quartile. Ito yung interquartile range natin. And we can say na yung atin palang quartile deviation is just equal to 1/2 of our interquartile range. Kasi yung interquartile range nga natin is the upper quartile minus the lower quartile already. So ito po yung formula natin. Next, we will be talking about the mean deviation. Mean deviation is the statistical measure of the average deviation of the values from the mean in a sample. It is calculated by finding the average of the observation. The difference of each observation from the mean then is determined. Okay, and then the deviations then are arranged, and this analysis is used to calculate the sporadic observations from the mean. Kung gaano ba kalayo yung atin pong value from the value of the mean. For the value of the observation from the value of the mean. So, ganun po yung gagawin natin for the mean deviation, and Here, meron daw tayong difference between the observation and the mean is determined and we denote this as x minus mu. So, mu stands for mean. So, wag po tayo ma-confuse ha. Minsan gumagamit tayo ng mu for sample and gumagamit tayo ng x bar for the population. But parehas lang silang patungkol sa mean. Parehas lang po silang average. Okay. For example, collect and count your data. Ito po yung ating first step. For any set of data values, the mean is the measure of central value. At take note na kapag nagsosolve po tayo ng measures of absolute dispersion, ginagamit po talaga natin yung measures of central tendency. And one of it is the mean. Kaya nga po kanina pinag-usapan natin yung mean. Okay, depending on the type of data, the mean tells you the central value of that data. So for example, ito po yung scores natin. The first thing that we're going to do is to collect and count your data. So after that, let's find the mean. Ano nga ba yung mean ng scores na to? Okay, add natin. We have the formula for mean. So yung mean daw natin, let me just introduce this one as mu. It is equal to summation of x, or the summation of scores divided by the total number of scores. So if we're just going to get the summation and divide it by the total number of scores, it will be the summation of these scores divided by 6. It will give us a result of 8.33. Okay, so ngayon para mas madalian tayo na isolve yung ating mean deviation, isulat na lang natin yung mean na katabi ng score so that kapag pinag-subtract natin sila, madali lang po nating makikita yung difference. So, especially when you are using Microsoft Excel, madali lang yan because that column subtracted by the column number 2, it will give you the result for the mean deviation. Okay, so calculate the deviation of each data point. Ibig sabihin po, isosubtract lang po natin yung score doon sa ating mean. It will give us, it will give us 2 minus 8.33. Also, we have 5 minus 8.33. We also have 7 minus 8.33. 10 minus 8.33. 12 minus 8.33 and 14 minus 8.33. So, yun lang po yung ating mean deviation. Okay, and it will give us a result of negative 6.33, negative 3.33, negative 1.33, 1.67, 3.67, and 5.67. So now we have calculated the mean deviation, and then after that, we're going to find the absolute value. Ano nga ba yung absolute value? So these are just the values inside these brackets. So yung bracket na makikita natin na ganito, that is just the absolute value. So we can say that this one is the mean deviation. Ano nga ba yung mean deviation natin ulit? This is just equal to x minus mu. So kung x minus mu yung mean deviation natin, therefore we can just say that the absolute value of the mean deviation is just equal to x minus mu. So going back to my question earlier, ano nga ba yung absolute value? So yung absolute value po, any number that will be put inside this absolute value will be positive. So ibig sabihin po kapag yung isang number ay naka-raised into or inside the absolute value sign, positive lahat ng values niya. So kapag ilalagay natin, for example, yung ating 6.33 into the absolute sign, it will result to 6.33. And this one will be 3.33. The other one is 1.33. We also have 1.67, 3.67, and 5.67. These are the absolute value of our mean deviation. Okay, after obtaining the absolute value of our mean deviation, we have to find its average. So, paano ba natin makuha yung average of the mean deviation? meron na tayong summation. This is already the summation of our absolute value. So, yung pag-calculate po natin ng mean, kagaya lang din po ng pag-calculate natin ng mean dito, which is equal to the summation of our mean deviation, which is just equal to x minus mu over the total number of scores, which is equal to n. So x bar is just equal to summation of x minus mu, which is equal to 22, divided by yung number of scores natin is equal to 6. Then therefore, it will give us a value of 3.67. Okay, this will be our answer for the average or the mean deviation. So how can we interpret these results? So for us to be able to interpret this, we know that the value that we have obtained earlier for the mean is equal to 8.33. So para malaman daw po natin or para ma-interpret lang natin, so the values are just 3.67 and we also have 3.67 here. So this is how we interpret our uh, mean deviation. Okay, next we will be talking about the standard deviation and the variance. So the variance is the average square deviation from the mean, while the standard deviation is just the square root of the variance. So both measures reflect variability in a distribution but their units differ. Magkaiba po sila ng units kasi yung isa ay standard deviation, yung isa ay square, yung isa ay hindi. Okay, start muna tayo with the variance. We have the formula for the variance and it is denoted as S squared. It is just equal to the summation of our scores minus our mean squared over n minus 1. So ito po yung legend natin. X is the score, X bar is the mean, and n is the number of samples. Again, yung X daw natin minus our mean uh, squared over n minus 1. This will be the formula that we're going to follow for the variance. So, tandaan po natin yung mga important things dito. Kailangan natin ng x, kailangan natin ng mean, at kailangan natin, ano po, kung naaalala nyo to, this is just the mean deviation. So, kailangan po natin ng mean deviation. This is just equal to x minus x bar or x minus the mean. And then, we're going to get the square. Hindi na po natin kailangan yung absolute value nito kasi kahit naman hindi absolute value yung value natin dito, kapag i-square natin siya, it will always result to a positive value. Then we have a denominator which is n minus 1 and it determines the number of samples. Okay, ito naman yung standard deviation natin. Madali lang naman kapag nakuha natin yung variance, kuhanin lang natin yung square root nun. That is the standard deviation. And as you can see, parehas lang siya ng formula. Ang nadagdag lang is the radical sign. Okay, example. The birth weights in pounds of 5 babies born in a certain hospital on a certain day are 9.2, 6.4, 10.5, 8.1, and 7.8. Find the variance and the standard deviation of the weights. Okay, let's start with this one. So, yung steps natin sa pagkuha ng variance, first, it's that we have to find the mean. Kasi naalala po natin, ang kailangan natin ay yung score. Siyempre, given yung score natin, then kukuhanin natin yung mean para makuha natin yung mean deviation, which is equal to x minus x bar, or the mean. And after that, we're going to find the square of this dun sa ating isang column, which is x minus x bar squared. Okay? And then take the average of the squared deviations. Okay, so let's have this one. The birth weights in pounds of 5 babies born in a certain hospital on a certain day are 9.2, 6.4, 10.5, 8.1, and 7.8. Find the variance. and the standard deviation. So kagaya ng sinabi ko kanina, variance muna tayo kasi mas madali nating makuha yung standard deviation if we are going to start with the variance. So ganun lang din naman pala yung process. Kasi kapag inuna mong kuhanin yung standard deviation, square mo lang yun na yung variance. Pero una mo talaga makukuha yung variance bago mo makuha yung standard deviation. Okay. So, anyway, let's have it first. Ano ba yung mga factors na kailangan natin dito? So, una, according to our formula, kailangan muna natin daw kuhanin yung x bar. And x bar is just equivalent to the mean. So, yung summation po ng scores natin sa x over the total number of scores. So, ilan yung scores natin? We have 1, 2, 3, 4, 5. Therefore, pwede natin itong masolve by just x bar is equal to the summation of the scores divided by n, and it will result to 8.4. So, dahil may 8.4 tayo, we all know that x minus x bar, this is our mean deviation. So, i-recta na natin. We have 9.2 minus 8.4, it is equal to 0.8. 6.4 minus 8.2, it is negative 2. 10.5 minus 8.4, that is 2.1. 8.1 minus 8.4, that is negative 0.3. And 7.8 minus 8.4, it is negative 0.6. Okay, again, you don't have to get the absolute value kasi baka magdagdag lang yun ng column. Hindi na po natin kailangan kuhanin yung absolute value kasi i-square naman natin siya. And any number na naka-raise sa power of 2 will result to a positive number. Kahit negative number man yan, basta naka-raise siya sa power of 2, magiging positive yan. And kapag kinuha natin yung third column, which will be our numerator, it will result to these values. So yung square ng 0.8 is just equivalent to 0.64 followed by the following values. So nakuha na natin yung ating mga kailangan. Yung s squared daw natin is just equal to summation of x minus x bar. Tama ba? Squared over n minus 1. So, ito madali na yung n minus 1 kasi alam na natin yung n. Ito na lang yung kailangan natin. So, meron pa pala tayong kulang, yung summation. So, we have to find the summation of these values. Okay, if we're just going to add them together, it will give us a score of 9.5. So, meron na tayong value ng summation of x minus x bar squared, which is 9.5. Now, it is easy for us to determine the variance kasi given na yung ating mga values. So, the variance is just equal to this formula. Okay, apply lang natin, substitute lang natin yung values natin. This is already the summation, kung naalala nyo yun sa ginawa natin kanina. So, meron na tayong numerator at meron na rin agad tayong denominator. This is just equal to 9.5 divided by n minus 1, and n minus 1 is 5 minus 1. It will result to 9.5 divided by 4. And 9.5 divided by 4 is equal to 2.375. So, pa-counter check na lang, it is equal to 2.375. This is our variance. So, na-solve na natin yung isa. This is our variance. This is 2.375. Okay, so madali na nating makuha yung ating standard deviation. Just get the square root of the variance or just the square root of 2.375. It will give us a result of 1.541. So let's see. Counter check pa rin natin para sure tayo. For the standard deviation, pwede nating i-substitute yung scores natin dito. We have S. S is equal to square root of, we all know that x minus x bar squared is just equal to 9.5. So, kuhanin lang natin. This is equal to 9.5 divided by n minus 1, it is equal to 5 minus 1. So, yung s daw natin is just equivalent to the square root of 9.5 divided by 4. And it will also give us a result which is equal to 1.541. So, either of the two methods, so, ang ginawa lang naman natin, in-expand lang natin yung formula dito. No? Pero parehas lang sila. We just have to get the square root of the variance for us to be able to obtain the standard deviation.
Now, we will proceed to the discussion of the measures of relative dispersion. So, what is measure of relative dispersion? So, these are unitless and are used when one wishes to compare the scatter of one distribution with other distribution. So, these are just used in comparison. That's why it is being called as relative dispersion. Okay, we have what we call standard score. It measures how many standard deviation is above or below the mean. So note that not really a measure of relative dispersion but related somehow. So the standard score. Okay. This is computed as z is equal to x minus our mean over our standard deviation. And the sample counterpart is z is equal to x minus mean pa rin over our standard deviation. This the other one is for parameter and the other one is for the sample or statistic. Okay, now let us have an example. Rowan got a grade of 75% in English and a grade of 90% in history. The mean grade in English is 65% and the standard deviation is 10%. Whereas in history, the mean grade is 80% and the standard is 20%. In which subject did Rowal perform better? So, sulat muna ulit natin yung formula for us to determine which of them is better. So, for Z, this is just equal to X minus X bar over our sigma or our standard deviation. So for English, sulat muna natin yung for English. For English, the grade Rowan got a grade of 75% and the mean grade is 65. So we have here 75 minus 65 for English, then divide it by the standard deviation of 10. And then for history naman, for history we have Rowan got a grade of 90%, so that is 90 minus our average or the mean grade is 80. Then the standard deviation is 20%. So let's try to solve for this. So we have 75 minus 65 is 10 divided by 10. It will give us 1. Okay, and for the history, we have 90 minus 80. It is 10 divided by 20. It will give us 0.5. So based on the values, we can therefore conclude that Rowal or Rowan perform better in English than history. So this will be our solution. Again, as we can see the values, Rowan has performed better in English in comparison to the history. And this is where we're going to end our discussion for the measures of position, measures of central tendency, and the measures of absolute dispersion. So God bless everyone, and God bless with your midterm examination.